Ready? Okay. So this is additional topic 2 and our final AP topic.
Yay.
So it was back in the book as Theorem 5.9. And it is something that they always ask about. There's probably at least one question on the exam about this always. I've seen it in the last several years. It's not too hard though. So it's one of those few theorems we had to learn. So let's go back and just think about what are the only theorems that we need for AP Calc that are the big ones. The fundamental theorem has part 1 and 2. One of them we just use it without thinking all the time. The other one we don't use quite as often, but the AP test will, I'll show you. Use one of those. If you really know one of those fundamental theorems well, and I'll show you when we start seeing problems, it allows you to solve all their hardest problems. It's like a trick that I've seen it's like in all their exams, and we'll go over that trick enough to where you guys will get some of those hardest ones. Okay. What other theorems do we have? That was a big one.
There was a squeeze theorem, but that one wasn't very...
Squeeze theorem is more Calc 2.
Yeah.
They use it more in Calc 2. We had Rolle's theorem, good. Yeah. What was the bigger version of Rolle's theorem?
Didn't it start with an M?
Yeah.
It did.
The mean value theorem.
Yeah.
Rolle is just a special case of that, remember? Good. And then we had like an intermediate value theorem, which just said how like basically described precisely how stuff is connected. We will. And I think we had one more. I'll leave it to you. See if you can think about it. But that's it. So this theorem is also kind of big.
You could just tell
Is
us.
it like average values or something like that? Average value, yeah.
Good job.
This is our last theorem. I'm going to call it, you can call it what you want. It doesn't have like a real famous name. I'm going to call it like the inverse derivative theorem. You might write that if you want, just for a name if you want to remember it. We'll call it like the inverse derivative theorem. So let me write it down. Punchline in red.
What ends a G?
Ing.
Yeah.
Is that like X?
Have you been watching Avatar a lot?
Kind of weird E symbol.
That means X belonging to that interval. It's
okay.
lying on that interval. Okay, so what this says is that if f is a function that's differentiable on some interval that you're deciding to look at and investigate, and if f has an inverse function, so you have to assume that it's invertible, because not everything's invertible, okay? And g also has to be the inverse of f, we're calling it g. If g is also differentiable on that interval, then you can calculate g prime of x by going 1 over f prime of g of x. Now this might not seem immediately obvious as to why it's important, so I think we'll probably try to do something without it and see what happens, okay? I just want you to keep this in mind while we're doing this, so I'm going to put this in here too. So consider some point, so let's just think one at a time. And that's really what we're going to be doing here. We're not going to be doing the whole interval at a time, a to b. We're just going to be doing like dealing with one point at a time, one x value at a time, okay? So that x value obviously has some y value, and I just want us to remember from algebra 2 or whatever, like how that point relates to f and how that point relates to g. So if g of x equals y, then what else do you know? Remember, you're assuming here that g is f inverse.
F of x equals x. F of g of x equals... F equals
It's a good idea though.
F
You're
of
trying to
y equals
compose
x.
them.
Yeah.
Inverses, the definition is that you reflect over that y equals x line, right? You switch x and y values. That's what an inverse is. So I just wanted to remind you that that's what that means. Let's put in here somewhere that, remember, we defined f inverse of x is g of x. Okay, that's what g of x means in this whole thing. Okay, that's what that means from algebra though. Inverse means switch x and y, whether you think about it graphically with a reflection over this line, or whether you just think about it algebraically. Okay, so here's an example. So let's see, I'm going to erase everything except the red maybe.
So there's like
Let's see if we can stick it up there
5x
somewhere.
plus 2, you say 5y
Okay.
plus 2.
So let's say we have this function. A fourth x cubed plus x minus 1, some kind of transformed
Is that
snake function.
That's just f of x?
Some kind of transformed snaky polynomial. Yeah? So the question is, well, a couple parts. But A is, what is f inverse of x when x equals 3? Okay. Did they ask anything about a derivative here? So you think we're going to have to use this yet?
No.
This is just part A. So, how can we do that? I want f inverse of x. This is f of x. Do we have f inverse?
No.
No, and in fact, if you switched x and y and tried to find the inverse explicitly like we've done in other classes, would it be real easy on this one since it's got...
There's a cube.
Now, you might be able to do it. But the thing is, on some functions, you definitely can't do that, right? Like, finding the inverse explicitly is like either impossible or really hard. And that's what this thing's going to let us do. It's going to let us get around that. Okay, you don't have to always find the inverse explicitly. Sometimes it's
Well,
just
can't
impossible.
you just plug x in and then
Plug what you get in again.
Okay, so let's try that. So you're saying, like, why don't you just plug x into here?
yeah.
Why don't you see what you get? Give me it with a calculator or whatever. You could do it. I guess you could do that as 27 fourths plus.
Or 9 fourths plus
2,
27.
So what is
plus
it? Give me the decimal.
31, 4.
31 fourths. That sounds right. Maybe not. A little more.
It's 7.75 is what I got. 7.75.
Confirm it.
I did it on the
I got
calculator.
8.75.
I got 8.75.
Okay, maybe I had it wrong.
Did you
I have 6.75.
add the 2?
So if you put 3 in, you get 27. 3 cubed is 27, right?
Okay, I got 8.
Plus 3 minus 1 is 27 fourths plus 2.
27 fourths is the 6.75, but then you have to add the 2.
Is that right?
27 plus 8 is 35.
And then 35 divided by 4 is 8.75.
It is.
Yeah.
Wait, so that's f of 3 and 8.6.
Right. How does that help us with this?
Yeah.
This is a good strategy. I mean.
Why?
F inverse, if that's true, thinking about what we have over there in blue, then all we know from this is that f inverse of...
8.75 is 3.
Is that what they asked us about?
No.
No, they asked.
So the only way to like do this by plugging in is to very cleverly...
Think about what equals 3.
What equals 3, not plugging in 3, but what equals 3. Is that going to be a very fun deal to do?
No.
I don't know, but you just figured out how to do this because you're Todd. I mean, he's got it. He said, well, it's not plugging in 3, it's figuring out what equals 3. Now that might be hard to do in your head, right? Oh yeah, that's going to be hard to do in your head, but can't you write it down? What equals 3? And then solve that equation however you want. In other words, once we did this, we said, well, that didn't work. Darn. So what we really want is f inverse of 3 blank. We're trying to fill that in, which means that for f, if you switch them, it's that, right? So 3 in the y position for f. So we've somehow got to relate this back to f. That's the real key here. And we're using that basic idea from Algebra 2 to relate it back to f. This is what we want. That means if we switch them, that's what we have to work with, which means that this is what we need to solve. Does that make sense? It's a little bit tongue twisty, kind of mind bending, but not too bad. Now, how could you solve this? You could say 0 equals 1/4 x cubed plus x minus 4. You could try to factor. That's not going to factor super easy because the cubed, right?
So could you just graph it?
Yeah. So
like
graph it.
you
So
would
you
graph
get-
3.
Yeah, I would, personally. If you can solve this by factoring or something, though, don't take the easy way out. Remember, you don't know what they're going to ask you to do on the non-calculator part of that exam. It's probably not going to be too bad, but you want to practice what you can do. If it's just something you can't do, use your calculator. I'd see the cubed and say, well, I don't know how to solve that, so I'm probably use the calculator. So I get x equals what?
2.
Make sure you see that Todd got 2. See if you get 2.
I got closer to 3.
Yeah, I'm gonna have to.
In my notes, you know what I did right
I
here?
got 2.
So this is really natural to think of trying to do this first, just like you guys were trying to think of doing, right? So I put right here, instead of this, I put... Darn.
What is it? Oh.
Sad face. Okay, so that's when they just asked us to, without even seeing the inverse, calculate a value for the inverse. So do you guys see how you can do that now? You don't even have to know the inverse explicitly to calculate a value for it. So that's kind of nice.
But okay, so to find the inverse of that, how do you? I just don't remember how to.
You'd have to go like this, right? To find the inverse of this, you'd have to go x equals 1/4 y cubed plus y minus 1 and somehow solve for y by like factoring. You'd go x plus 1 equals, then you'd say, oh, how do I take the y's out of that?
You can
If
pull
I
up one y, but that doesn't do much.
then you have this.
1/4 y squared.
And you're just like, well, I wasn't able to pull it out, so solving for y explicitly would be very difficult. That's what I'm saying. So it's a problem sometimes. That's why this whole theorem exists. Sometimes solving for things explicitly is really hard, and you just have to leave them implicit and work with them implicitly. That's what this theorem's all about. It's like the implicit derivatives theorem, something like that. I'm developing more names for it all the time, right? Okay. B is the real thing. This is the real calculus part, right? So I could have asked this question to my Algebra 2 classes. I'd get 3 people who could answer it, but, you know, that's the game. So the real question is, what is the value of, I'm going to write it like this time, just in case you see something like this.
So that's where you use the 1/.
Mm-hmm. So what's another name for this? F inverse prime.
G prime.
We're calling that, you could call that G prime of X too, right? And this is really G prime of 3 that they're asking us for. So basically what we're supposed to calculate here is G prime of 3. You can write it F inverse prime of 3, D dx, F inverse of 3, you know, all those different ways. Here's another way they could have written it. They could have written this.
Over dx.
Evaluated at x equals 3. There's all those different notations, right? You want to be prepared for. I doubt they'll give you that one, but you can certainly see that in engineering texts. Anyway, so we go, Todd says 1/. That's the rule. That's what the theorem says. So you go 1/.
F prime of g of x.
F prime of That's the only thing that's wrong with that. Remember, you can use F inverse for G if you want to call this F inverse, or if you want to call it G. That's just a comfort thing for you. I like G because I can clearly see it's a distinct, different thing, you know. And the F inverse, the -1, doesn't like distract me. But it's a judgment call. What should I have in here that's slightly different?
3.
Surely have 3 there. And the question is, do we have that information already? I think we already did it in part A, didn't we?
Mm-hmm.
What was G of 3 going back to part A?
2.
G of 3 was 2. Oh yeah, we had it over there, right? So the only question is 1/F prime of 2. How would I do that?
Well,
take a derivative.
Yeah.
F prime of x is
3/4 x squared plus 1.
Then plug 2.
that was F of
Okay,
x, take
so-
derivative. Yeah.
Okay.
And then just plug 2 into that.
Plug 2
So
in.
we've got 1/4 times 8
Oh, wait.
So 3 plus 1 is 4.
plus 2 minus 1. Is that right? Or did I do something
You
wrong?
don't have a minus
Did I do
1.
something wrong?
You don't have a
Wait,
minus
it's 1/4 or
1.
3/4?
2 squared is
You subtracted.
Oh,
Isn't that
3.
a, okay, so,
And
Thank
then
you,
where'd you
Allison.
get the minus 1?
Wait, did you use
3/4
F of
times 4.
I was looking at the wrong thing.
Yeah.
Yeah.
It's 3/4 times
4
4.
plus 1.
2 squared, or 4.
Which equals
My
4.
goodness.
Which equals 1.
What happens if you have 2 zeros? Like if it's quadratic, just regular?
It's like this. Are you talking about over here?
Right, like that. You only had 1 because it was an odd exponential.
so
If it's
x
even, you have like
equals
2
what
or
is g
4.
of 3 equal to?
It's a good question, Brett.
Yeah.
I think it would depend on the problem.
Inverse of x.
Like this only had one clear zero when you graphed it.
Yeah, but if it was a parabola,
Okay,
you
so
had
then-
like 2 positive.
F inverse and g.
Inverse of
Plug
3.
There'd be 2 questions. You're not gonna get into that in Calc 1, but that would come up sometimes. So I think the answer would be what region of the number line, what interval are you looking at? You have
Okay.
to decide based on that. Or based on, they'd have to like give you some other like initial type of, some kind of other condition.
Okay.
They'd have to specify there, and if they didn't give you, so like if you're doing research in the real world, you're gonna have to decide which one of these do I want to use, or maybe I should use them both. Maybe they're both legitimate. They could both be legitimate. Maybe there's 2 values for that. It's possible.
Okay.
You know what I mean? Good question. It's a good question. I think we're done. I think that's all we need. So there's that theorem. There's how to use it. Ta-da.